Welcome to Introduction to JavaScript Promises. So today we'll explore what promises are and how they're used in handling asynchronous operations in JavaScript. So to give you a definition, a promise in JavaScript is an object that represents the eventual completion or failure of an asynchronous operation. So this is really powerful uh, because you can handle asynchronous tasks such as an API request or file operations. Promises, they have three states, uh, pending, which is the initial state to begin with, and another state is fulfilled, which is uh, the state that is in when the operation completes successfully, and uh, rejected is a third state when the operation fails. So if you look at this code example, you can see the basic structure of a promise, and we will delve into this in detail as we progress. Creating and using a promise. So if we are to create a simple promise, you will want to create promise with a constructor. Uh, the new promise you see here, the promise constructor is used to instantiate a promise. And this promise takes a function with two parameters. They are resolve and reject. And these are functions themselves, and they are uh, used to return the result of the asynchronous operation. So that's why uh, inside this you can see resolve itself and reject itself as a function. So if the operation is successful, we call resolve with the results, um, and we pass like promise is resolved successfully. If it fails, if the operation fails, we call reject with an error message. So this is how we can kind of simulate a condition for a demonstration. Then what we can do is we can then handle the outcome of the promise using then for success and catch for error. And this pattern is essential for effective asynchronous programming in JavaScript. Chaining promises. So promise chaining is a powerful feature. What it allows you to do is allows you to execute a sequence of asynchronous operations, one after another. So each then block, as you can see in the example, uh, what happens is it receives the result from the previous block. So the previous block uh, is here for this then, and previous block is here for this then, and so on. So it will, once it receives the result from the previous block, and uh, it returns a new value or promise. So you can see that what we're doing here is we multiply the result of the previous operation. So demonstrating how data is passed through the chain. So we have one here, and then we will multiply this result that this block received from previous block with 2. Then once we move to next block, the result becomes 2. And then we will multiply 3 by result, then the result becomes 6. And if we multiply this result with 4, then we will have 24. So, and another thing, say if any promise in the chain is rejected, uh, what happens is the control will jump right to the catch block, and the and it will console error and send a message, and then the finally block will execute at the end saying completed, and this finally block gets executed regardless of the promise's success or failure. So this is really useful for cleaning the operations up. So error handling in promises. Error handling is especially crucial in asynchronous programming. So with promises, error handling is streamlined using catch, as you saw from previous example. So when an error occurs in a promise or in a then block, the execution skips all subsequent then block and goes straight to the nearest catch block. So this mechanism helps in writing robust code that can handle exceptions gracefully. So in this example, uh, we are throwing an error intentionally to demonstrate how this error is caught in the catch block. If you're curious, feel free to like run these in your Node.js environment. Here, advanced promise patterns. So you might run into like a more complex scenarios. Um, when you're in a complex scenario, you might often need to control the flow of multiple asynchronous operations. So you can see that uh, we have 2 fetches, one fetch going into data 1, one fetch going into data 2. You might have noticed that we are using promise all here. So promise all kind of allows us to run promises in parallel and wait for all of them to complete. This is particularly useful when you have multiple independent asynchronous tasks that you need to synchronize. On the other hand, we have promise race. So this with inside promise race, we make same fetch call to data 1 and data 2, but unlike promise all, promise race waits only for the first promise to settle. So if data 1 is settled first, then uh, the that will be it. Data 2 might settle first. And what I mean by settle, the promise can either be resolved or rejected. So these patterns enhance the flexibility of handling asynchronous operations in applications, as shown in this example with multiple fetch requests. Promise chaining best practices. So in promise chaining, I want you all to remember to return a value or return another promise. By doing that, this you ensure that the next then in the chain receives the intended input. Be careful about unintentional, undefined returns because this can lead to unexpected results. So in the example that you can see, we're kind of showing you the like a typical flow. So it moves to then result, and you add one, and you uh, console log result, which will be 2 here, and then uh, we included like a throwing an error in the middle of the chain. So once we throw an error, you'll notice that the chain skips this then all the way to the catch block after the error, then continues with the next then after catch. So this kind of shows the importance of strict structuring the chain for clear error handling and flow control. Promises and event loop. So JavaScript's asynchronous nature is governed by the event loop. So understanding event loop is crucial for understanding promises. So in the provided example, you can notice the order of console logs. So although you can see that set timeout has a delay of 0, it's executed after the promises. The reason why is because promise callbacks have priority over callback queue tasks like set timeout. So the event loop processes the uh, promise promise micro task queues immediately after the current script, even before rendering or processing tasks like set timeout. So this behavior definitely impacts how you structure asynchronous code. Now let's look at error propagation in promise chains. So it's important to understanding how errors propagate through a promise chain because it's key to effective error handling. So when an error occurs, uh, what happens is the promise chain skips all subsequent then methods and jumps to the nearest catch. So if you look at this example, error is thrown at the beginning, then the first then will be skipped, and this catch block will process the error thrown in the beginning, and by returning a value. And once this catch block returns a value, it will allow the chain to continue. And this pattern is really useful for recovering from any errors and ensuring that the chain does not break. Uh, remember, uh, you want to make sure to remember that uncaught errors can lead to unhandled promise rejections, and this can be problematic. So promise all settled. Uh, this is a way to handle multiple promises. So promise all settled is an essential tool, especially when you want to perform several asynchronous operations independently. We looked at promise all. Uh, so the difference with promise all is that uh, pro it rejects as soon as one promise uh, in the array rejects, but promise all settled waits for all the promises to settle. Uh, doesn't matter what the outcome is. So promise all settled is ideal for situations where you need to know the result of each promise. So in this example, we handle like a mix of fetch request and manual rejection. It kind of demonstrates how promise all settled provides a detailed results for each promise, including both successful and unsuccessful outcomes. Lastly, async await. Async await is a syntactic sugar for promises, and it's used a lot in modern JavaScript. The reason why this async await is used a lot is because it really simplifies the way we write asynchronous code. We know that uh, asynchronous function always returns a promise, and this await keyword pauses the execution until the promise settles. So this async await syntax allows the code to look more synchronous and easier to read. So in this example, you can see that fetch data is an async function that uses await to wait for fetch request to complete before processing the response. And we can see that error handling is straightforward. We're using try catch block, which makes asynchronous error handling look very similar to synchronous code. And this approach is definitely cleaner, and it reduces a lot of complexity that we saw from chaining then and catch methods. Thank you, everyone.